Okay, well, I guess we have to do an example of an incline with friction. So let's take a look at an example where the actual object goes down the incline, something really large. I'll put real numbers in here, and much as I prefer doing it the other way, only because it gets a little complicated. So we've got the pulley, and we've got masses, and to make it less questionable, we'll say we have 12 kilograms here. And here we've got, let's say, 5 kilograms. And keep 5. And so clearly, even with a little, well, unless there's a tremendous amount of friction, the 12 kilogram should bring down the 5 kilogram in its way. So we expect this to go up and this to go down. The angle we'll pick here, let's say we'll make it a little steep, we'll make this 50 degrees to ensure that happens. And with friction, you have to make sure you do have the direction correct, because if you have it wrong, you will get a wrong answer. If there's no friction, the acceleration, if you pick the wrong direction, you'll get a negative answer telling you, nope, the object's actually moved in the other direction. Here, it'll just come out wrong because you end up selecting the direction of the objects. So, what I'm going to say is find the acceleration of the masses, and given that mu sub k, the coefficient of kinetic friction, we'll make it reasonable, 0.10. Mu sub k equals 0.10. So again, the first thing we're going to do is draw free body diagrams. And for this one, we have the 5 kilogram. And then we have the 12 kilogram. Now, as you noticed on the previous videos, if you examine them, on this one, we have a tension going up and a weight going down, which I'll label as 5G. You might as well use the numbers here instead of using M's. For the one on the slope, okay, so, oh, by the way, this one is going to be moving upward, so up is going to be positive, and that means any arrow pointed in that direction is going to be positive. Any anti-parallel arrow will be negative. Now for the 12 kilogram object, well, we do have a tension holding it back. Do that in red. We do have a tension holding it back, and we have the usual normal force perpendicular to the incline. And then we have our weight that's broken down into sines and cosines. And the weight pressing against the incline is going to be given by, in this case, mg cosine of the angle, or 12g times the cosine of 50 degrees. And we have a force going down. This is the component of gravity that actually pulls it down the ramp, and it's going to be 12g times the sine of 50 degrees, or mg times the sine of theta, as we had before. But we're still missing one force, and that is correct. That is the frictional force, and that's going to be given. Which way is that going to be? The object is going down the incline, so we expect that to be up the incline, countering the force. And the symbol is lowercase f with subscript k. It is not mu sub k. Mu sub k is just the ratio. F sub k is the actual force. So there's the free body diagrams. And now we want to look at the Newton's law for both x and y directions. Now the first one, we're only going to have a y direction. And for that one, it's going to be the sum of the forces in the y direction, and there are two forces. It's going to equal 5A, MA, so that's 5A. And we only have two. Tension is positive, and the weight, which will be 5G, is going to be negative, so that equals 5A. And we can solve immediately for T here. We see that T equals, well, at least in terms of variables, 5A plus 5G. Okay, and so now we look at the second mass, and we'll have to do both X and Y here. Y will be interesting because it will give us our F sub n. So for this one, we have the sum of the forces in the X direction. Now in the X direction, how many forces are there? Oh, let me draw my coordinate system here. The object is moving down the incline, so down is going to be positive. So that's positive X. This will be positive Y. It doesn't really make any difference. Any arrow pointed down in the X direction is going to be positive. So this arrow is going to be positive. This arrow is going to be negative. And this arrow will be negative. So as you can see, we have three forces in the X direction. And that's going to equal MA or 12A. So we've got three forces. Let's put them in there. We've got 12G sine 50, and we will calculate these numbers in a minute. We have minus the tension minus the frictional force equals 12A. All right, so we can start putting in some numbers now, but first let's do the Y direction first, and I will leave myself a little bit of room there. Some of the forces in the Y direction, there were 3 here, there's 2 here, is going to equal 0. You don't expect anything to happen, as I've said before, in this direction. The acceleration in that direction should be 0. So, back to our math, and we have some of the forces. Well, we see that this one is going to be positive, and this one will be negative according to our coordinate system. And so I get F sub n minus 12G cosine 50, and that's all going to equal 0. So my normal force is going to equal 12G cosine 50. And let's calculate that now. So that's going to be 12 times 9.8. And let's see, the cosine of 50 is 0.64. 0.64. And so times 12 times 9.8 becomes 75.6 newtons. That's my F sub n. That will be needed by us when we calculate the friction, F sub k, in the other equation. Let's calculate 12G times the sine of 50. And 12G times the sine of 50, so the sine of 50 is going to be 0.766, so we get 12 times 9.8 times 0.766 minus t. We'll take care of the friction in a minute, 12A. So times 12 times 9.8 gives me 90.1. I get 90.1 minus t minus F sub k. Now F sub k is going to be mu sub k times F sub n equals 12A. So now we can calculate the frictional force. I'll get 90.1 minus t minus mu sub k was 0.1. And the normal force is 75.6 equals 12A. So I get 90.1 minus t minus 7.56, 1/10 of that equals 12A. So minus 7.56. So we've simplified this down to 82.53 minus the tension equals 12A. All right, so what I can do now is I can take this, I don't know, I can calculate 5G and plug it into here. And if I do that, I get this. I get 82.53 minus tension. That's going to be 5A plus 5 times 9.8 equals 12A. Okay, we're getting there. This becomes 82.53 minus, should have another parentheses there, minus 5A. That's good, minus 5A, because the accelerations need to add minus 49 equals 12A. And we then get 82.53 minus 49 is 33.5 equals 17A. I've brought the 5A to the other side. Finally, A equals 33.5 over 17, which equals 1.97 meters per second squared. So it's not blazing acceleration, but it's moving downward. If you ever, I may have mentioned this in another video, but if you ever get greater than 9.8, if the object is falling on its own, then you know you made a mistake and you have to go back. That's it for this video.